This is Algebra 1, Unit 9, Lesson 4, Solving Quadratics by Inverse Operations. Okay, now square roots can be used to solve special type of quadratic equations that involve just a squared quantity. Alright, now there's a couple things that you have to remember. Taking a square root is the inverse operation of squaring. So if you take a square root, you are undoing a square. And remember, since these are quadratic equations, there should always be two solutions. When you solve it because it's x squared, there should be two answers. One is going to be positive, and the other is going to be negative. And unless you are told to eliminate the negative, you have to include them both. Okay, so let's look at how we solve a quadratic equation. To solve a quadratic equation is pretty simple. You basically do the same thing you would do when you're solving a linear equation. You want to get the x by itself. So in this case, to solve, you want to get the squared quantity alone on one side of the equation. All right, once you do that, you would take the square root of both sides of the equation. What you do to one side, you have to do to the other. All right, and then write the answers in simplest radical form, and don't forget the signs. Okay, so very simply, the first thing you have to do is get the x squared by itself. So for this first one, the x squared is by itself. X squared equals 16. Okay, now what we want to do is take the square root of both sides. If I take the square root of this side, I also have to take the square root of the other side. Okay, now what happens when you take the square root of a square? It cancels the square out because you're undoing it. The square root of x squared is just x. And also remember, there are actually two answers for the square root of 16. Square root of 16 is 4, but it's also negative 4. So to indicate that, instead of having to write x equals 4, x equals negative 4, you just write x equals plus or minus 4. Okay, so that means there's actually two answers here, positive 4 and negative 4. Okay, let's try x squared equals 100. All right, x squared's by itself. Take the square root of this side. Take the square root of this side. The square root of x squared, the square root cancels out the square, leaving an x. And the square root of 100 is 10, and it's also negative 10, so this is going to be plus or minus 10. So all you have to do is take the square root, put the plus or minus in front of it. Okay, now what if it isn't a perfect square? Well, then we want to put it in simplest radical form. Again, the square is by itself. Take the square root of both sides. And I have plus or minus 20 here. All right, but 20 is not a perfect square. What perfect square goes into 20? Well, 4 does. 4 times 5 is 20. So what is the square root of 4? Well, the square root of 4 is 2. So it's going to be plus or minus 2 times the square root of 5. All right, 4 is a perfect square, 5 is not. Take the square root of 4 is 2. Square root of 5 is square root of 5, and it's plus or minus 2 square root of 5, and that's as far as you can go. All right, now what do we do if the square root isn't by itself? Well, we have to get it by itself, just like you would if this was a linear equation. We want to get the x squared by itself, so we've got to move everything first. So the first thing we have to move is the 10. So we minus the 10, and that gives me 2x squared is equal to 18. All right, and then before I take the square root, I've got to get rid of this 2. So I'm going to divide by 2, and that gives me x squared equals 9. All right, now that I've got the x squared by itself, I just take the square root of both sides. And don't forget there's a plus or minus in front of the square root. So when you take the square root, it's going to be plus or minus the answer. And 9 is a perfect square, so it's going to be plus or minus the square root of 3. So x is going to equal 3, and x is equal to negative 3. Okay. X squared over 2 minus 5 equals 3. Same thing, we want to get the x squared by itself. So we want to move the 5 first, so we're going to add 5. X squared over 2 is equal to 8. And then since this is divided by 2, we want to multiply both sides by 2. And that 2 cancels out the 2, giving me x squared is equal to 16. All right, the x squared is now by itself. Take the square root of both sides. Don't forget there's a plus or minus in front of there. So x is going to equal plus or minus square root of 16 is 4. Okay, so x is equal to positive 4 and x is equal to negative 4. Okay, now here's a little challenge one. x minus 2 squared equals 25. All right, now you can take the square root of a binomial. That's okay. So since the square is by itself, this whole side squared is by itself, you can take the square root of the entire quantity. And if you do it on one side, you have to do it on the other side. And don't forget there's a plus or minus in front of there. Okay, so what happens to the square root of the square? The square and the square root cancel out, leaving just the x minus 2. That's a handy trick, so we don't have to remultiply this out and get it equal to 25 and set it equal to 0 and all that stuff. If you can unsquare the square root, you can take just the binomial is left. So this is actually going to be plus or minus 5. All right, now here's where you have to be careful. There's actually two answers here. All right, the first answer is going to be x minus 2 equals positive 5, but there's also x minus 2 is equal to negative 5. So there's two answers here because this is plus and minus 5. All right, so to solve each one, x is going to equal 7. There's one answer. And then add 2, x is going to equal negative 3. So there are two answers here. You just have to make sure that you have them both, the positive and the negative answer. Okay, so we've learned a neat trick. You can do that just by getting the square by itself. All right, it works the same way when you have a binomial squared, just get it by itself. So we're going to add the 50, and that gives me 2 times the quantity x plus 5 squared is equal to 200. Okay, divide this side by 2, divide this side by 2. That gives me x plus 5 quantity squared is equal to 100. All right, now that the square is by itself, I can take the square root of both sides. X plus 5 quantity squared is equal to plus or minus the square root of 100. All right, let me move this down a little bit. All right, the square root cancels out the square, leaving just x plus 5. Don't forget this is plus or minus, the square root of 100 is 10. Okay, so there's actually two answers here. There's x plus 5 is equal to 10, and x plus 5 is equal to negative 10. Okay, solve for x, subtract the 5, we get x is equal to 5, and subtract the 5 here, watch your sign, you get x is equal to negative 15. So you get both answers there. All right, so the goal is to get the square by itself so you can take the square root. Just remember there's always going to be two answers, plus and minus. All right, what do we do here? 5x squared minus 2 equals 38. Well, we want to get the x squared by itself, so we add the 2. And that gives me 5x squared is equal to 40. Divide by 5. And then I get x squared is equal to 8. Then I want to take the square root of both sides. Don't forget it's plus or minus. Okay, is 8 a perfect square? No, it is not. But it does have a perfect square in it. What perfect square goes into 8? It would be 4. 4 times 2 is 8. So x is going to equal plus or minus, what's the square root of 4? Is 2. And then this square root of 2 stays under the radical, so this is x is equal to plus or minus 2 times the square root of 2. So it's positive 2 times the square root of 2 and also negative 2 times the square root of 2. Always put it in simplest radical form if you can. Okay, let's try this one. X minus 3 squared plus 10 equals 38. Subtract the 10. X minus 3 quantity squared is equal to 28. All right, now the square is by itself. I can take the square root of the square is equal to plus or minus the square root of 28. Okay, the square root cancels out the square, leaving just x minus 3 equals plus or minus the square root of 28. Okay, does 28 have a perfect square in it? Yes, it does. 4 times 7 is 28. So this is going to be x minus 3 equals plus or minus the square root of 4 times the square root of 7. All right, what is the square root of 4? Is 2 again. X minus 3 is equal to plus or minus 2 times the square root of 7. Okay, now, since this is a square root, what we have to do is add the 3. But can we add the 3 to 2 square root of 7? No, because this is a radical, or this is an irrational number. When you add a rational to an irrational, you get an irrational. So this is actually going to be x equals 3 plus or minus 2 times the square root of 7. All right, technically what this is x equals 3 plus the square root, 2 times the square root of 7, and x is equal to 3 minus 2 times the square root of 7. Instead of having to write them both separately like this, you can write it as 3 plus or minus 2 square root of 7. It means the same thing. Okay, so make sure there's the two answers there when you do that. Okay, so usually you see it like this, but it actually means these two are the same, or these are the two answers that you need. All right, now let's look at a little application problem of the quadratic. What are the quadratics used for? All right, Frank graphs the parabola y equals 1/2 x squared minus 6 on the grid shown. Here it is. He believes the quadratic has zeros of negative 3.5 and 3.5. All right, remember what we said the zeros are? The zeros is another name for the x-intercepts. So he is looking at this and he says, oh, this is negative 3.5 and this is positive 3.5. All right, but is he correct? Find the zeros of the function's simplest radical form and explain why he must be incorrect. All right, so if it's the x-intercepts, we know the y has to equal 0. So if we take 1/2 x squared minus 6 is equal to 0. Add the 6. 1/2 x squared is equal to 6. Multiply both sides by 2. We get x squared, because these cancel out, equals 12. And then we have to take the square root of both sides, plus or minus. And then that means, in simplest radical form, x is going to equal plus or minus, well, 12 has 4 in it. It's 4 times 3. Perfect square is 4. So it's going to be plus or minus square root of 4 is 2 times the square root of 3. So my two answers, this one is going to be negative 2 times the square root of 3, and this one is positive 2 times the square root of 3. Is that equal to 2.5? Well, if I grab my calculator, and let me put y equals 0 in here. There's my original equation. Here's y equals 0. If I do the intersect here, second trace, intersect, enter, enter, enter. And I want to go to this one over here. Enter. Is that equal to 3.5? No, that's approximately about negative 3.46. That's pretty close, but it's not exactly. All right, so for x equals negative 2 times the square root of 3, that's approximately 3.46. It's pretty close to 3.5, but not exactly. All right, now for x equals 2 times the square root of 3, let's look at that one. Second trace, intersect, enter, enter, and then if I go over here to do the other one, okay, enter, it's also about 3.46. So this is going to equal plus or minus 3.46, or this one's negative, and this one is positive 3.46. So it's close, but not exact. Okay, so you can't say it's exactly negative 3.5 and 3.5 because that doesn't work. Okay, even if I put in 2 times the square root of 3, y equals, if I put in 2 times the square root of 3, enter, it's 3.464, which is not 3.5, unless we round it off, and it didn't say to. All right, so you can see zeros are not always nice even decimals. They may be irrational, which is perfectly fine. Okay, so we want to find the zeros of this function's simplest radical form. So that means we set it equal to 0. All right, add the 20. And that gives me x plus 4 quantity squared is equal to 20. Got the square by itself, take the square root of both sides. Don't forget your plus or minus. The square root cancels out the square, leaving x plus 4. And then plus or minus 20 has 4 in it as well, so this is 4 times 5. So x plus 4 is equal to plus or minus, what's the square root of 4? Is 2 times the square root of 5. And then we have to move the 4 over, but the 4 can't add to the 2 because that's part of an irrational number. So x is going to equal negative 4 plus or minus 2 times the square root of 5. Okay, then you can put that in your calculator Negative 4 plus or minus 2 times the square root of 5 is going to be your answer.